This kind of machine, the Singer 201, you will normally find that the maximum thread size it can handle is a V69 thread. When you have that kind of thread, it will normally require of the heavier materials the top tension to be about 2 to 3 Newton. It is actually thread dependent what the tension will be. The maximum for the normal machine will be 2 to 3 Newton. You have a spring in there that looks like this. What happens is it presses these plates together, and the spring will in a way be used for that. But when you go to the maximum here, you are actually able to squeeze the thread, and this one is pressed all together, and then you actually is able to increase the tension of the thread to maybe 8 Newton or something like that. But when you measure, the thread tension becomes very unstable, and when you try to pull it up with these dynamometer, you can see that it's very bad. So never try to squeeze this tension here at the top, because you will never get a good result on that. If you are serious about thread tension, you like to measure it, and you can do that with this kind of spring dynamometer. This one is up to 2.5 Newton, and you measure it like this, just to pull it up. And I got this other one up to 20 Newton, and you can measure it by pulling the thread up like this. Very easy instruments, and they are cheap to get. I got another video telling a little more in detail about these. When you start to go from a serial fill 40 to a serial fill 20, there's a huge difference in what is required from the tension. From a level of 3 Newton, you need to have about 7 to 9 Newton. It cannot be achieved with the normal springs here. And then I tried to get more heavy springs from the internet, and actually some European companies did say they sell them. And unfortunately, when I got them, they were not more heavy. They were just like the other ones. And when I measured the diameter of the spring, here it's about 1 millimeter to 1.2 millimeters of the normal brands. I didn't know actually what to do, but then I tried something, and I had this one of stock. It's actually a hook to be used on shock cords, rubber bands. Here you have got a spring thread of about 1.5 millimeters in diameter. So I took a couple of pliers, and then I started to make a spring myself. And it was actually possible. With this kind, I made a new spring to put in, and with this spring I can adjust the tension of this serial 20 from about 1.5 Newton up to about 10 Newton stable. This was actually necessary to get a balanced stitch on some heavy materials. I got this picture from college sewing machine parts in the UK. The spring looks like it is quite heavy. It is for a Singer 132K6 machine. I don't know the dimensions of this spring, so I can't say whether it will fit into ordinary sewing machines. I got some similar heavy springs I have seen on other sites, and I have made a link to them below. Please try yourself, ask the supplier about the dimensions, or just try to buy one and see if it fits. Of course, I would like to know if you will find one that fits in an ordinary machine. This is one Beehive spring I bought. When I press it like that, I feel that there is some friction or a clicking going on, and that's not good, and it is because some of the threads here are sliding against each other. So that's not good for a reliable equal thread tension. The other one has nothing like that when I press it. So it will not cause any problems in thread tension. This is 5 Beehive springs for tension that I've got, and you see here one is from a Singer 66K. This is a spare part I bought. This is from a 201K. This is from a Singer 237, and this is a spring I made myself. And this is the diameter of the steel thread used. I did some measurements on these springs, and you can see it now. This is how I measure the height of the spring when it's not loaded. And here I got a kitchen weight with a wooden bar above it. So in this way I'm able to put the Beehive spring below this bar and can measure the pressure that the spring makes. And finally I am able to measure the spring length when it is under pressure. In this way I was able to calculate the spring constant of these 5 springs, and you can see it in this small table here. Please hold the video if you will look closer to that.